Okay guys, so let's go ahead and look at the warm-ups. We're going to look at them together up here. And I'm going to be asking you questions about it as we go through them, just to make sure everybody's got it. Alright, so taking a look at number 1. Dan, can you tell me what you did on number 1? You moved the whole thing, so you made it 1 over 27 then to the positive 2/3. Okay, and now what? The cube root. So what's the cube root of 27? And then square it. 9. So you should have had 1/9. Did everyone get 1/9? Okay. If you didn't get 1/9, you should go back and look at it. But recognize that you could also do this on your calculator. You could literally type this in as 27 raised to. Now, if you have a newer calculator, the exponent automatically shows up. But on mine, I have to do parentheses because it's an older one. I get this answer, and then if I math bracket, then it's going to tell me it's 1/9. Okay, so we can check that. All right, what about on number 2? Number 2, Kara, can you tell me what you did?
I multiplied by 1, but it was like the cube root of 2a squared.
Good, and why did you choose that?
Because before a needed another 2 and then 2 more a's to get them out.
Good. So we had to have the cube root because now we have 4 times 2, which is 8a to the 3rd. And these are both perfect cubes. And then on the top, we're going to have the cube root of 3 times 2 is 6a squared. So then we're going to have the cube root of 6a squared over, and then the cube root of 8 is 2, cube root of 8 to the 3rd is a, so 2a. Hopefully you got that one right. Okay, what about number 3? Ando, can you tell me what you did first?
Well, first I multiplied the exponents by the negative 1/3, so you get 4 to the negative 1/3 and 6 to the negative 1/3.
Good, now what?
The negatives, you switch them, so it's 6 over 4, not 6 over 4.
Excellent. Okay, how about number 4? McKinley, can you tell me about that one?
Well, first I multiplied them together. That's 33.
Okay.
Then I kind of last year to 43, and I got it set 6, so I wrote that 3 times 3 times 4 is 5.
Okay.
I got 4.
Okay, so you're saying that this is 3 to the 5th. That's good. So you just had made a factor tree to figure that out. So we already knew that 243 was 27 times 9, right? That was given. So then we know 27 is 3 times 3 times 3, and 9 is 3 times 3. So you're right, yeah. Now you also could have written it instead of 3 to the 5th. You could have said it's 3 to the 4th times 3 to the 1st even, maybe. And so then we've got the a to the 8th b. Okay, and so then what was your final answer then?
3a squared.
Very good. Okay, so right at that. All right, what about number 5? Number 5, how did you do this one? Gabby?
First, I thought I had 1 space,
Okay. So you added the exponents and got what? Okay, so you got to the negative 1. So you added the exponents. Very good. Okay, then what did you do?
and then I thought that they were both negative, so first it was negative, supposed to be 1/3, so it's like negative 1/2.
Good, so it's 3 to the 1/2. Very good. Now, what if the question said to write it in simplest radical form? Do you know what that would be in radical form? Very good. All right, awesome. Okay, how about number 6? Chloe, what did you do first on number 6?
I learned that way, so first I learned it like that, like the 4th root of 16, then I most of my practice that was 40, and then the times 3, third time that I learned the 4th radical, and then I get that down to 4 times to the 4th radical of 3, for like photographic. I didn't get it.
Okay, let's go back to this part then. So you were saying then that the 4th root of 16 you knew was 2, right? So then we take the 2 out and we multiply it by what's already out there. So we had 8 4th root. That we took care of. That we could not take care of. Okay, numbers that multiply to be 243. You might just have to get out a calculator. Can it be divided by 2? Definitely not, right? So we're going to try the next number. Let's try 3. Can 243 be divided by 3? Yeah, it's 81. So it's 3 times 81. Does that help you? Do you know the 4th root of 81, Chloe? It is 3. And the way that I know that is because 81 is 9 times 9, and these are all 3s there. So then I should know that the 4th root of 81 is going to be 3. So now I'm going to have minus 2, and I have to take out that 4th root of 81 is 3. So what's going to be out here now then, guys, everybody? 6, 4th root of 3, because that could not come out. So now these are like terms, and so our final answer then should be 2, 4th root of 3. Did a lot of you get that right? Very good. All right, so now we're going to come down here, and I want to talk about transformations. And I'd like you to open your student journal to page 136. And before we do the problems on the paper, I want to talk a little bit more about these rules. And the two, actually there are 3 that I think are the most difficult ones. They're these, the horizontal translation. Because we've always said that if we want to go 2 units to the right, we just put minus 2. But it's actually that the x has to get replaced with x minus 2. Okay? So you've got to think of replacing the x. Anytime you're doing something horizontally, you are thinking of replace the x. Okay? And that holds true here as well. If we're going to do a reflection over the y-axis, this means that we have to replace the x with negative x. So again, replace x with negative x. The verticals are not as difficult because they're kind of more intuitive. But with the horizontals, these can be difficult. With the horizontal stretch or shrink, we have to replace the x again. So we basically replace the x with a 1/3 x. In fact, I don't even like the way they say this. When they say, they're telling you what this does, but if you were asked to shrink by a factor of 1/3, the x gets replaced with a 1/3 x. Okay? Alright, so now let's do a problem, a kind of challenging one. So let's say that we have the cube root of 2x plus 3. And for this problem, we're going to do a reflection. We're going to do all the difficult things. We're going to do a reflection in the y-axis. We're going to do a shift to the left of 2, and we're going to do, then we're going to do a horizontal shrink of 1/2. And we're going to have to do it in these orders, this order. We're going to do a reflection in the y-axis first. So we're going to look up here. To do a reflection in the y-axis, we replace x with negative x. So if I'm doing this, I would really call this f of negative x. That's how I do a reflection in the y-axis. I replace the x with negative x. And so I get this. That's the first step. Now we're going to do a shift to the left of 2. That does not mean, everybody listen closely, that does not mean that I'm just going to put plus 2 under the radical. That is not what it means. If I'm going to do a shift to the left of 2, that means I have to take this function and I have to replace x with x plus 2. So I take this function that I have, and wherever I see that x, I have to replace that x with x plus 2. That's going to be a shift to the left of 2. It's not that I just put plus 2 out here and get negative 2x plus 5. That is wrong. I have to replace the actual x with x plus 2. So now I'm going to have the cube root of negative 2x minus 4 plus 3, which is the cube root of negative 2x minus 1. And the last thing I'm going to do is a horizontal shrink of 1/2. That does not mean that I just multiply this negative 2 by 1/2 necessarily. What this means is that wherever I have an x, right here's my x, I have to replace it with, and then if it's a horizontal shrink of 1/2, do I replace it with 1/2 x? What do we replace it with? 2x. That x gets replaced with 2x, and then we have the minus 1. So our final function, we're going to call it g, is the cube root of negative 4x minus 1. That's the function that would do all of that. Okay? You have to go in the correct order. Whenever anything involves the horizontal direction, then you have to replace the x and not just under the radical. Questions on it? All right, now let's go back to the paper that I gave you. Some of your papers may not have this cube root. I forgot to put it on some of them, and then I tried to add it on. So put cube root right there because they have to be the same types of functions. So on this, we're going to describe the transformation that would happen if we start with this and we go to this. For this, we want to think of our order of operations. See, in the other one, we have to make sure we go in the order at which we're told to do it. But in this case, we have to go by our order of operation. So the first thing that would happen to x is it's getting multiplied by 1/2. What does that do if an x gets multiplied by 1/2? Yeah. That's correct. Good, great. So we're going to have a horizontal stretch of 2. That's the first thing that happens. Okay. The second thing that happens, if you were to plug in an x value, you'd have to multiply by 1/2, take the cube root, then you would do this, right? That would be the next thing that would happen. Hunter, what's that going to do, that negative out in front of just that? What does it do? Good. Flip over x-axis. Or you can call it a reflection in the x-axis. That means the same thing. And then, after we did that, then we would have plus 3. McKenna, what's that going to do? Nicely. What's that going to do, the plus 3? Yeah. So that would be called just a vertical shift up 3. Okay, makes sense? Order's important there. Okay, now let's look at number 8. Let G be a reflection in the x-axis followed by a translation 1 unit right of the graph of this. Alright, so we're starting off with this function. We're coming up with a g of x function. So the first thing we want to have is a reflection in the x-axis. If you don't remember what to do, look at your student journal. But I think we all know this by now, right? A reflection over the x-axis, we have to multiply the whole function by negative 1. So this entire function gets multiplied by negative 1. But we can't go inside the radical. So to do that reflection, it's just going to be negative 3 fourth root of x minus 1. Now, if we'd had a polynomial function, like let me just show you real quick this other type. Let's say we had f of x equals x squared plus 3x minus 1. What would a reflection in the x-axis be for this one? Can somebody tell me for this one what the difference is? What would the reflection in the x-axis be for this? What do you think, Alex? Yep. So in this case, the entire function gets multiplied by -1. But if we have a radical, we can't go inside of it. So it's just going to be the negative on the outside. So there's the difference. Okay, and then the last thing it says is followed by a translation 1 unit right. Again, that does not mean that I'm just going to do -1 here, necessarily. What it means is that wherever I have an x, I'm going to have to replace that x with an x minus 1. So you see how in this case it doesn't really matter, but if we'd had any other constant in front of that, then it would have mattered. So we're going to have -3 fourth root of x minus 2, and that would be our g function. Don't forget to put g equals, or else you get points off. 1 point. All right, we're going to save this one and do it as a warm-up tomorrow. So switch gears here, go back to your student journal. Page 137. Okay, so we already did numbers 1 and 2 yesterday, the graphing and the domain and range and everything. So now we're going to look at number 3. It says to describe the transformation if we have this graph that goes into this graph. So what do you think happened there? Kenneth? Do we agree? Grace, is that what you were going to say? Yep. She is correct. This is going to be a reflection in the x-axis. Our book always says in instead of over. I like over, but we'll go with it. Questions on that? Nothing else happened. So now let's go down to number 4. It didn't do anything. No. Because if I reflect this over the x-axis, that means that everything gets multiplied by -1. So this term gets multiplied by -1, and this term gets multiplied by -1. So that's all that happened. Did not get shifted down. Okay? You could have said this. You could have said, no, I'm not going to say that. There's nothing else you could have said. That's it. Let's look at number 4. Write a rule for G if G is a horizontal shrink by a factor of 5/6, followed by a translation 10 units to the left of the graph of this function, cube root of 15x plus 1. All right, so we're trying to come up with a G function. We know it's still going to be cube root. Think about what we would do if we want a horizontal shrink by a factor of 5/6. Does anyone know what to do? What do you think, Andrew? Good job. So everything inside of here stays the same, except for the x is going to get replaced with 6/5 x. That's our first step. Now, I should go ahead and simplify that while I'm at it. When we're going to multiply this, let's do 15 divided by 5 and then times 6. What is 15 divided by 5 and then times 6? It's going to be 18x plus 1. So we took care of this. Done. Now we're going to go to the next part. Followed by a translation 10 units to the left. I am not just going to put plus 10 under that radical, or even outside of that radical. Okay, now what do I do? You got it. So wherever I have an x, I have to put in an x plus 10 plus 1. And then we have to simplify. So this is going to be 18x plus 180. And then if I have 180 plus one more, that's 181. And that would be it. That looks like it would be a lot more than a shift to the left 10, doesn't it? When you just glance at it? Let me see if I still have this in my calculator. Nope. Let me put it in there. Watch. I go under math. I'm going to go down to cube root of 18x plus 181. I'm going to do a zoom 6, which takes my screen to negative 10 to 10. There's the way it looks. Do you see how it is? That is just a shift to the left 10. Okay? So that is going to be correct there. All right. Number 5. Use a graphing calculator to graph 8x equals y squared plus 5. Identify the vertex and the direction that the parabola opens. So they're already telling us that this should be a parabola, aren't they? Now, how would I get this into calculator-friendly form? Calculator-friendly form means I have a calculator here and all it has is y equals. So what am I going to have to do to this equation? Solve it for, yeah, okay. Huh? Okay, we're going to have to solve it for y by subtracting 5 and then taking the square root. Okay, so I'm going to rearrange this. I'm just going to use the symmetric property to rewrite it like this. And now I'm going to have to subtract 5, and I get y squared equals 8x minus 5. So now I want to get y by itself, so I'm going to take the square root of both sides. What do I always say we have to do when we take the square root of an equation? But what? Plus or minus. So we're going to have positive 8x minus 5, and we're going to have negative the square root of 8x minus 5. We're supposed to graph this on our graphing calculator. So in our y sub 1, we're going to have to put in the square root of 8x minus 5. In the bottom one, we're going to put in, second function, negative the square root of 8x minus 5. Let's all just go ahead and do a zoom 6. And there's our parabola. Does everybody's parabola look that nice? Does everybody's get connected right here? I know some of the calculators, they don't exactly connect it. Okay? And I think that's kind of a glitch with the calculator. The older ones actually did a pretty good job at it, but some of the newer ones do not. How many people do not, they don't touch? Okay, so you're just going to have to recognize that this is a parabola and that they should touch. Okay? So here's what we're going to do then. We're going to copy this graph. Now, doesn't it look like it's not at 1, that vertex, but what's the y value at that vertex? 0, isn't it? So if I want to find out where the vertex is, all I have to do is plug in 0 for y. Can you see that? How the vertex is right there? So I'm going to plug in 0 for y. And then I'm going to solve for x. And that's going to be where that vertex is. So that vertex is not at 1, it's not at 0, it's not even at a half. It's actually at 5/8. I'm going to use my table to come up with some other good points. Okay. And it's not giving me any really pretty points, is it? Okay. So we're not going to worry about it being too exact. We're just going to get the basic shape down. And it looks like this. There weren't any nice integer answers to really graph, but so that's good enough. Okay, so our vertex then, let's just jot this down. Our vertex is at the point 5/8, 0. Let's go ahead and talk about the domain and range too. The domain would be the x's that we can use. What are the x's? Well, this actually, I take that back. We really shouldn't find the domain and range. Does anybody know why? We only find domain and range for functions. Is this a function? It's not, is it? Because it doesn't pass that vertical line test. So we're not going to talk about domain and range. We found the vertex. The direction that the parabola opens is to the right. See how it's opening this way? So it's opening to the right. Okay? Question? All right, let's do the same thing for this one. We want to use a graphing calculator to graph this. So again, I'm going to use that symmetric property, and I'm just going to switch these around here. Just get my y squared on this side, on the left side. So I'm going to subtract 49. I now have negative y squared equals x squared minus 49. Before I take the square root of those sides, I want to get rid of this negative. How do I get rid of that negative in front of y squared? I want to divide by negative 1, don't I? And now what would we do? Take the square root. What do I have to put in front? Plus or minus. Does anybody know what shape this would be just by kind of looking at it? If I took this y squared over, it would be x squared plus y squared equals 49. Do you recognize that kind of equation? Circle, isn't it? Yep. So it should be a circle when we graph it. Let's see if our calculator can handle this. Mine will probably be okay. Let's see. So we put in second square root, negative x squared plus 49. And then negative the square root of negative x squared plus 49. So I'll do a zoom 6. And mine is not so great on this one either. It's not connecting it. Does anyone's connected, or is everybody kind of leaving that gap? Yeah, the reason it doesn't connect it is because it thinks that it's not a function right there. It thinks it's trying to graph a vertical line, and so the calculator kind of gives out on it. But we should know enough to be able to graph this very well. How far out would we go, guys? What's the radius of this circle? Do you remember from geometry what the radius would be? 7, yes. So we're going to go out 7. I didn't make my axes so great there. That's all right. I'm going to count it, I'm going to go by 2s. 2, 4, 6, 7. 2, 4, 6, 7. 2, 4, 6, 7. 2, 4, 6, 7. And then we're just going to make the circle. And it asks us to identify the radius. So what would our radius be? 7, we just talked about it. And then also to find the intercepts. The intercepts means where it crosses the x and the y axis. So can you write out all those points? Write out those 4 points on your own, what those intercepts would be. Logan, can you tell me what they are?
7, 0, 0, negative 7, negative 7, 0, and 0, 7.
Very good. Okay? Any questions on that? Not too bad, right? Okay. That's all the new notes and everything for today.